intro presentation on what Clarisse is and how it's used, and then Jan is going to go ahead and get into it and show you guys how cool it is. So if anybody has any questions during the presentation, feel free to type them in to the question box over here on the right. We'll try to answer anything we can at the time. Otherwise, we can hold questions that Jan will need to answer to the end, and we'll also have a Q&A at the end. So feel free to just hold your questions till the end if you want as well. So with that, I'm just going to go ahead and pass it over to Jan, and we'll get started.
Okay. Hi. Thanks everyone for listening. So I will explain you what is Clarisse. So basically, it's a next-gen 2D, 3D graphic software running on Windows, Linux, and Mac OS X. So what can I do with it? It's a software to do look development. You can also, with it, do 3D matte painting and camera mapping, procedural modeling. And so here is an example of a forest using only 10 small assets. So all the scattering is drilled procedurally in Clarisse. You can also do scene assembly, layout, animate, and basic rigging. So by basic rigging, I mean stuff like vehicles, rigid, for example, a robot, but you cannot animate, for example, a skinned character at the present state. You can also texture, light, and shade, render, compositing, and do pre-compositing. So here's a few examples. So this one is a Adidas commercial done by Stock Digital. So all the 3D CG crowd and the stadium is done in Clarisse. This one was done by a school. So here is a pack shot. This one show 3D matte painting. So everything is in 3D in this scene. No paint over. So we see what we can do. So what can't I do with it? So I can't paint textures. I cannot model geometries. I can't animate characters. I can't simulate. And I can track and do advanced compositing in Clarisse. Like what by advanced compositing, I mean rotoscopy, keying, a lot of things important for CG integration with live action. So thank you. Now you will see the demo in Clarisse. Here is the interface. So, of course, the user interface can be customized to your needs. You have some preset layout for animation, render, and you can also make your own from scratch this way. You can divide the UI and choose in each part of the user interface various parts of Clarisse. So pretty classic system. I will start with this layout. So I will rebuild a scene you may already seen, little canyon scene with some spaceship flying over a desert. So to do this, I begin to import some geometry in my scene. So I will load all of the little objects except this one and this one. Okay. So now Clarisse is loading all of these polygons. You will see there is almost 7 million of unique polygons here. So the loading is very fast, and Clarisse don't use a lot of memory to do this. You can see. Okay, so the process uses only this to load 7 million of unique geometry. Now I will build a little layout from this. So I will move this object in a more visually pleasing way. Just resize some objects. Okay. So all of this geometry was built in ZBrush and exported directly with a little decimate, but it's almost a raw object. So we'll resize this one, which is okay. Sorry. Okay, so I will now copy and paste this object to create a canyon. So a very interesting thing in Clarisse is when you copy paste data, Clarisse knows it. So in traditional software, when you want to save memory, you must think technically. So you must, for example, use instancing when to save memory when duplicated things. Here in Clarisse, I will show you a little widget showing this. You can see in red, this is the memory used by Clarisse, and in green, this is the memory Clarisse should use if there was not this system of deduplication. So I will copy paste this object, and you can see the memory is almost the same. I will copy paste it again, so you can see again almost the same memory, but the green bar is now much higher. So what it means is in Clarisse, the artists don't have to manually optimize things. You can just build your layout the way you want, and all the optimization will be automatic. So I continue to copy paste different objects to create some paths. And we also have an interesting tools to copy paste objects in a more artistic way, which is the 3D tool. So, but I control click on my source, and to place copy, I just have to click where I want my copy. So you can just place your object this way. Okay, I will just replace those. Okay, so you can very quickly build a lot of complexity. Here I have 50 million polygon. This is very low for Clarisse. You can see it's still very fast. You can also combine objects together. So I will explain what combining is. because it's a unique concept to Clarisse. So here I have a little rock. Okay, this one. So with this this little rock, I will make a little 3D pattern. So I again use my 3D stamp tool. I will add some variation to the rotation and maybe some scaling. Okay, so I create some rocks, and now you can define all of this as a new scene item. So I right-click, combine, and now you have a new element in your scene, which is just a list of objects. So if you look at the attribute of this object here, it's just a list. So it's fully procedural. If, for example, I move this object, you can see it move here. And again, the memory is almost the same as before, because all the geometry is only once in memory. So, and you can also combine combiners together. So you can build things hierarchically. For example, if you think about desk in open space, you could build a combiner with a computer, a mouse, and some papers on a combiner which is the desk, and you can create another combiners with the desk and the computer, mouse, etc. Inside, and one cubicles of multiple desks containing combiners can itself be another combiners, etc. So you can also build city with this system. So I have the 3 combiner. I combine this into a new one, and again you can see it is fully hierarchical, because if I pick, for example, this first element, it moves inside all the combiner. So I will just, oh, sorry, it is a beta of the 2.0 version, so sometimes you get some crash. Fortunately, the load and save is very fast, and by default, Clarisse save every 5 seconds, so you don't lost a lot of time. So I will, okay, this time it's okay. I will undo this. Just delete the last 2 and keep this one. Okay, and now you will see a more procedural way of building things in Clarisse. So the combiners is procedural, but there is a more procedural system. I will introduce you to the point cloud scattering system. So basically, what is the system is a point cloud system. So here is the point cloud, and it's a point generator. So it takes as input geometry. So you pick, for example, the ground, okay, and set some density. I will choose a density of 1. So you get all those points on your ground. And now I only want points in intersection between the geometry and the ground to place, for example, little rocks on my landscape. So I will use for this an occlusion texture, and this introduces you to a very specific concept of Clarisse. any feature can be used for very different things. For example, the occlusion one is a texture used for shading, but it can also be used to place geometry. The texture can drive any attribute in Clarisse. So I create the occlusion texture, and in the point cloud, I will set the decimate texture to the occlusion. Okay, so nothing happens because currently my occlusion texture returns a white color because I didn't set up my occlusion texture. So how to set up it? Basically, the occlusion texture needs a list of occluders objects. It's important to be able to control what objects are taken into account, because you will see Clarisse can load a lot of things. You can, for example, work on multiple shots, so you must specify what the occlusion texture see. So I will, I create a group, and inside this group, I will define the geometry list we'll use for the occlusion. So I will take all of these, okay? And now I will just raise the radius to maybe 100 meters. Okay, now you can see the effect. You only have points where there is occlusion between the ground and the cliffs. I will raise it a little. Okay. So now we have all these points, and now we want to use them to scatter geometry. So we just previously set up some little rocks in a combiner, so we'll use this combiner to multiply on the ground. So I create a scatterer. So the scatterer is the object which take a point cloud to position object and a geometry list to copy this object on the point. I add my rocks combiners, okay, and my geometry support. So it's a point cloud. And now you can see 74 billion of polygon scattered on the ground. So you can see it's very, very complex geometry. Not very well optimized, but it's really not a problem in Clarisse. Really, when you start using Clarisse, you stop counting polygons. So now I want maybe the rocks are too big, so I will just scale them a little bit and introduce some variation in the scale and in the rotation. You can see the interactivity while I adjust these attributes. It's always very responsive. Okay. And all is procedural because and it is very, very important in a team. All the geometry you see here is not saved in the project. It's always external geometry file. If, for example, I click on this object, you can see in the attributes you have just a file name pointing to a LWO file. In this case, it's using the Lightwave file format, but you can also use OBJ and, most importantly, the ABC Alembic file format, which can carry animation with deformation, animatable topology, for example, for object which change topology from frame to frame, which is very useful if you want to destroy things. for example, an exploding wall. All of these can be imported using Alembic. Okay, so now I have my little set. Just to show you, this 3D view is very fast because it's not using at all OpenGL, but instead it uses a ray tracer. And it is the same ray tracer as the final render engine of Clarisse. And if I switch to image view, which is the final render, there is absolutely no delay because the data is shared between the two. Internally, it is only one system, so you don't have the geometry twice. And to get a final render from this, you just have to add shaders, lighting. So I will stop with the layout building by using a pre-made one. So you will see how to use file referencing and scene assembly. So I start by opening a project containing an animated camera and okay, this one. And from this project, I will import all of my assets. So I will just move this in context. I will name it my shot. Okay, move this here. Okay, so this is my shot. And now I will load my pre-made asset, but as reference. So I use file, reference, file, and I will reference other Clarisse projects. So in Clarisse, a reference is a regular Clarisse project. It's not, you don't use a special file format for referencing. So I use this one, which is a BG background sphere for the sky. And this one is the ground with the cliff, just as I built before. This one is the lighting. I will import also this one and this one. This contains the shading, and this one some spaceship with animation. Okay, so everything is loaded. Takes some time to load the 7 million polygons. Okay, so I will just put this one at the root of the project. Okay, so basically in Clarisse, you can see these folder structures, an image. So this object is an image defined by a resolution. So an image, see every object at the same level and at levels below itself. So you can see all my geometry with the animation, but everything is white because all of these projects only carry geometry without any shading information. But if you look at this reference set project, so you can see the reference path here, you can see materials. So I will just load my okay, my alternate layout. Okay. So I go to my material. So you can see some materials nodes here. And all of this is inside the reference set project. And at the root of my shading reference set project, I have this little object called the shading layer, and it is an object containing roles to automatically reapply shaders depending on the name of the geometry and the shading groups. So you can load a wide geometry and have all your shading referenced from a different file and automatically reapplied on your shot. And the nice thing is it's shot dependent. So shot by shot, you can assign a different shading layer. So I will select my image. Inside your image, you see your 3D layer. I will come back later on what 3D layer is. And I set my shading layer. Okay, apply, and now Clarisse will apply all the shading automatically to this scene. So it's very easy to separate shading and geometry to different files to work on a team. Now I will open the shading layer file in a new Clarisse. So, for example, I am the log dev artist who are in charge for the shading, and someone asked me to change the color of the spaceship. So I open my shading project. Okay. So inside I have only one spaceship and a very simple set, and I click on the object to select the shader, and I will add some node, for example, multiply node to change the paint to a blue color. Okay, and maybe I want to add more reflection, so I will add another multiplier to the reflection. Okay, and we'll change the glossiness of the reflection to have a softer reflection. Okay, so now it is my new look dev file. I just have to save it. Okay, and now if I return to my shot, I just have to click on reload resource, and it's done. All the reference is updated, and I get my new shader. So this example show you the referencing and the shading. Of course, you can also change your lighting. For example, I have here my light set, referenced light set, and I can change the path to take, for example, a cloudy version. Okay, so here is the cloudy version, and maybe my background must be cloudy too, so I will switch my background geometry to a cloudy one. Okay, and now I have the cloudy version. You can also, in some case, apply local override to the referenced file. So, for example, only for this shot, but I don't want to modify the light set for other shots. I want to have a brighter sun, so I will go to the lighting ref. I select my sun, and I will, for example, change the intensity, maybe the color. Okay. And if you want to clear the override, you can, if you want to revert back to the referenced file from the light, from the lead lighter, I just have to use the clear button, and you get the original one. I will just set back to my sunny lighting, okay, and my sky to a blue sky one. Okay. So now I will just add some random plants to my shot using the exact same technique I showed you just before. So I import a pre-made project. Okay, in my shot, and I will just set the occlusion group to use the ground geometry. Okay, and the ground input to use the ground. Okay, so I will now have nice plants and rocks on my landscape. It takes some time to build because there is an insane amount of geometry. I have 13 billions, almost 14 here. You can use it, see it in the 3D view. It's really an insane amount of detail. Not very well optimized, but okay, it works. I will return back to my image view. Now I will push a little the quality. So I go to my ray tracer. We use the Monte Carlo renderer, so you can set your anti-aliasing sample here, and it will push the quality of the global illumination, reflection, blur, etc. So I will set it to 3, not a very high number, but it will be enough for the demo. And I will turn up the motion blur. Okay, it's a little nicer. And now we want to have some layering in this image. So I will separate in 2D my background, my sky, and my spaceships. So to do this, I open my layer editor. So in my image, so it is the image you see here. I have a different 3D layer. By default, I have only one. You can see it here. And I will rename it sky. I will duplicate this one and rename it cliff, or maybe set. Okay. Add another copy and rename it spaceships. Okay. Each layer is a full 3D scene. So I will modify the visibility to only see a part of the 3D data for each layer. I lock my attribute editor to be locked on this layer, and here you can see the visibility group, and you can define groups to specify what geometry each layer can see for the camera, the light, the shadow, the ray tracing, and the global illumination. To do this, it's very simple. You just have to select your geometry, drag and drop it, and it's done. You get automatically a group with the geometry inside. So I will hide it and do the same for my set. And this time I will drag and drop my set geometry. Okay, it's done. So you don't see anymore the ships, and you don't see anymore the vegetation and the rocks too, because I didn't add them to the group. So I will go inside the group and will add the plants and the rocks. Okay, so now this one is okay. And you still see the shadows of the spaceships, for example, because if you look at the visibility, you are still using all the visible geometry for the light, shadow, and global illumination. So only the camera sees this limited geometry set. So I will finish with the spaceships. Again, I lock my attribute editor, and I will select my 3 spaceships Okay, now I have a layer with only the spaceships. Again, you can still see the reflections of the set and the spaceships. So I have the spaceships, the set, and the sky. And if I display the three, you get a composite of the three. And the nice thing is it still works interactively with animation, for example. And Clarisse will recompute on the fly the three different 3D layers. Of course, you can also add 2D filters. For example, I will add a defocus on the set. Okay, defocus. So it's very handy to pre-composite your 3D, and you don't work blindly. You always see your results in real time. Of course, you can use Clarisse to build a final composite if you don't need advanced compositing operation for live action, like I said previously. But if the tool set of Clarisse compositing is enough for you, you can build your final composite in Clarisse. In case you need to finish in an external compositor, you can output all this layer in separate AXR files. So each 3D layer have an output. You can see here, render to disk. So you can get all your pre-composite layer in your final compositing software. You can also output any custom AOVs you need. We have a very powerful AOV system inside the shading graph. You can output any part of the shading graph in an AOV. So it's really a mix of lighting, shading, and layout tool with a compositor. I will load another project. We show you a very specific aspect of Clarisse. Okay, which is what we call the picture-in-picture system. So here it is. Just waiting the Clarisse to compute this. Okay, so again you see a different layers. So we have a background. This one is just a glow, so not very important, and some spaceships, the same as before. So the first layer is very classic. It's just a 3D object renderer, the classic one. But this layer is way more interesting because you can see the rendering of this one is very fast because it is a 2.5 3D system. If I open the 3D view in previous mode, okay, you can see how it works. So this layer uses 3D cards like you can do in a compositing system, but in ray tracing, so you can get a reflection very easily because you have access to the full render system of Clarisse. But the interesting thing is each texture of each 3D card is a full 3D scene. So you can see here this little image. So each image is a texture rendered by Clarisse in the same project. For example, I will select, I will just lock this view and will open a 3D view using this one, for example. Okay. So everything here is rendered for this card. And if I, for example, if I pick this object and move it, you can see the texture updated in real time. This is what we call the picture-in-picture. And so we have different folders, and basically each folder contains a little scene with some object, some light, etc. And the nice thing is if you go back in the image view, if, for example, you want to change the lighting, each little scene have an instance of the main global light. I have a global lighting folder with 3 lights, and each little mini scene have a linked copy. What we call the instance in Clarisse is very different. It's more like a linked copy with object sharing parameters. So all of these lights are the same as the global one. So if I rotate my sun, each texture will be recomputed on the fly. So you can see each texture is re-rendered. Just need to wait a little for each texture to be updated. Maybe I have something okay, I think I will close it. Yes, don't want to wait more. Maybe it is crashed. Not sure about this, but don't want to waste your time. Okay, so I will open it back. Okay. Pick back the autosave. And just a nice thing I just wanted to show you on this scene is you can globally change the wall lighting, but you can also on any object localize a shared attribute. So for example, if I pick my lighting, my global lighting, only for this layer, I can, for example, localize the intensity. Oh, sorry, not this one. Okay. So I will localize the intensity of my send, and this time it will only change for this layer. And so you always have the choice between sharing parameters and keeping separate. I will speed up to have some time for question and answer. So just to finish, I will just show you some different examples, like the city map. It's not the same time and seeing a finished image and the loading and computing of the project directly in Clarisse. You can see the loading is always very fast. I will not wait to finish this one. We'll just load another one using an interesting use of the picture-in-picture system. In this one, you have an HDR image generated on the fly by Clarisse and used to light an object. So you don't have to use software like HDR Studio to do this kind of setup. You can do it directly in Clarisse. You can see I have reflector and lights with a panoramic 360 camera outputting this image using on the fly to light and reflect on this object. I can, for example, move the reflector and you can see on the fly the system updated. I'll rotate this, and again all is recomputed on the fly. So always is Clarisse is always very procedural. And just to finish, and I will leave the session for question and answer. On a production example using deformation, because I just show you rigid geometry, but of course Clarisse works very well with character animation, things like that. So this one is use production data animated in 3ds Max and exported with Alembic. So it uses an actual use of Clarisse. So all is referenced to be able to work in team. This one. So this time all the data is in Alembic file format, exported from 3ds Max. So you can move the timeline and scrub through the animation. You can see the motion blur on deformation. And again, this one was using the shading layer system to procedurally apply on the fly all the shading, which is very important to reapply shaders from one shot to another. Okay, thanks for your attention. Now you will start the question.
Yeah, I have a couple questions here, Jan. Felipe just wanted to know what kind of computer setup you're using. Like, what is your graphics card? What kind of CPU, etc. are you using on this demo machine?
Okay, this one use dual 6-core Xeon. It's an old one, from 2 years ago, with 2.4 gigahertz So it's approximately 50% faster than one of the fastest i7 you can buy today. So, and it's 2 times slower than the modern Xeon dual CPU Xeon. And about the graphic cards, it uses a consumer NVIDIA, not a Quadro, and it's not very important because Clarisse don't use at all the GPU. It only uses it to display the user interface and the 3D handles. So you can, for example, use an integrated Intel graphics card. It's perfectly okay for Clarisse.
Okay. Michael was asking, in the 3D, when you use the 3D tool, is there some sort of snapping mode, like in terms of geometry intersections?
Currently, we don't have snapping. It will be added very fast because one of our customers asked for snapping tools, and we had very soon snapping feature. But this one uses a ray, so it fires a ray on the geometry and places the copy at the intersection. So it's a kind of snapping, but we don't have, for example, grid snapping.
Yeah, okay.
Just Brett, may I add something? Jan, maybe you can display the clone stamp on a sphere, because I guess the question was about if the geometry snaps to the geometry you hit on. So if you have a sphere, for example, it will hit on the surface of the sphere. So if you can just demo it, just
Yes.
clone stamp cubes on a sphere.
So this is an implicit sphere. If I look at the wireframe, you don't have polygon on this one. It's a mathematical surface. So I will add a box, and now the 3D tool, using the box as the source, I will, okay. So it plays, in this case, the center of the box on the surface of the sphere. Or on the box itself.
So it's basically, yeah. So it's basically putting the geometry on the underneath geometry. So it can be anything. Even if Jan import the spaceship, for example, he can place the cubes on the spaceship itself.
Even on volumetrics.
Okay, I think this is a related question, but what about if you're setting your 3D characters using Ornatrix hair from 3ds Max?
We import git splines. So we didn't test Ornatrix, but if it can't output spline to Alembic file, it's okay. We have two ways to render hairs. You can either export the full hair definition, each hair in a GID, to Clarisse, so you will get exactly what you have in Max. Or you can also use our styling system. So basically you export only a fraction of your GIDs, for example 10,000, and you can use Clarisse to interpolate the fur guides to the final density with custom controls to freeze the fur. For example, we have a clamping tools too. You can control the clamping with textures. So it has been used successfully in production using this true system.
Okay, and what about SSS materials?
We also have SSS. We have built-in SSS materials. It is very close to the Pierman implementation. I can show you the controls. So it's use a ray trace dual scattering system. it's a physical system. We don't use point cloud, so you don't have to wait for the render to start. Maybe I can show you on this sphere. So I will just add to my box the materials. Okay, so I have SSS, and I will change the distance so you will see it better. SSS scale. Okay, you can see it here. You can set change the albedo. It uses a wavelength system to change the color along the ray. You can see some color shift. You can adjust this here. Okay, so. And again, it has been used on characters successfully.
Okay, and if somebody's usually working their scene in V-Ray, is it better to do the shading process in V-Ray?
No, you must. If you want to render in Clarisse, of course, you must use Clarisse materials. So you can do some texture testing, for example, to preview some maps in Vray, but it doesn't make a lot of sense to do this. The usual workflow is to do all the shading and texturing in Clarisse. For UV mapping, you will do it in your host application, but everything related to shading must be done in Clarisse because it's a different renderer, so we don't have the same attributes. You cannot convert a Vray shader to a Clarisse one. We have a pretty similar feature set, but not implemented the same way, so it's not compatible.
Okay. He's also asking, what about flickering problems on the renderings?
It's very close to other ray tracer. Basically, when you have it's a brute force renderer, so you won't have GI flickering like when you use irradiant sketch, but you could have a grain. But if you don't see grain in a still image, it will be perfect in animation. So it's very close to Arnold in this way. So you must raise the number of samples to get the noise gone. Of course, the more sample, the longer the render time. But it's very classic in this way.
Okay. Back to the hair. Can the imported hair be influenced by geometry? Like, can it interact with imported dynamics, or can it be animated, secondary animation?
When you import the guide with ABC file, of course you import the animation too. So, and again, the interpolation system reacts to the animation on the guide. You won't do the dynamics in Clarisse, but you import animated guides. So it's designed to work with animation this way. We don't have a physical animation system in Clarisse, so you must build your dynamics and your character animation in Max, Maya, Softimage, whatever you use. But it's of course it works in animation with motion blurs too. So.
Yeah. Okay. Michael is asking, when I'm texturing procedurally, are there selection sets like in 3ds Max?
when you texture procedurally, I don't understand exactly what you mean by selection set for texturing procedurally.
All right, Michael, maybe you can just type that in exactly, clear that up a little bit, what you mean by selection sets. And in the meantime, if anybody else has any questions, of course, feel free to type them in. But also, if anybody is interested in a trial of Clarisse, you can send me an email and I can get you set up for that. It's a full trial, not the PLE version. So if you want to email me at brad@motionmedia.com, I can get you set up with a trial so you can check it out for yourself. Let's see, Michael's saying, like, when I have a wall with a lot of bricks, randomize
Yes.
texturing for the entire wall.
Well, yes. How you would randomize the texture in the wall, for example. We have different way to do this. We have utility texture with object ID, so you will be able to use, for example, this to control a texture switcher. So I will show you the texture switch. So basically, you can add multiple map. So map file. So this will be your different texture. Okay, you will send all of this to the texture list of your switcher. You can see the list here. And you will choose the input using the utility texture set to object ID. So each break will have a different ID, so we'll have a different texture. This is a way to do it. You could also output a vertex color from Maya or Max or whatever on each break to have different vertex color on each one to control the switch. There's a lot of ways to do this. But
Jan, can you
possible.
Jan,
Yes?
Jan, can you switch the 3D view to previs so you can actually see what you're doing? So just show the example and put, instead of putting map file, maybe procedurals in it.
Yes, because map file, of course, don't have example. I will just choose different colors. So constant color. So this will be my texture. So for example, one blue and one pink and one green. Okay. You can see each box have a different one. So it's very simple to set up this kind of thing. You can even control the scatter list with this kind of texture. For example, to have a mix of plants, like in a system like Forest Pack, or it's very, very, very powerful. Don't because all of these nodes can be used not only to control the shading, but also any attributes of geometry. So it's very, you can use it to drive a lot of things.
Okay.
Any other question?
Yeah, Chris is asking about toon shading. Do you have toon shading?
We don't have built-in toon shader, but again, you can build toon shading this way. For example, using gradient with light incidence, or I can show you. For example, maybe I will create a texture gradient and a Lambert one. And I will just turn off my diffuse. Okay, and use this. Okay. If I change this to step, it's easy to have toon shading like you can also use AOV and the live compositing system to add filters to this. I can use, for example, also some noise with a bump map. Okay, so I can get interesting effects this way. But the line, you can do it using for a very small occlusion texture combined with the incidence gradient to get a line. You put this material as an override on a 3D layer, place this layer on top of geometry shaded this way, and you can get a very nice toon result. But we don't have a preset toon shader. We could ship Clarisse with one. It's just a project. It would just be a project file you can use and apply on your objects. It's very flexible to. You can design very easily this kind of shaders.
What about lens flare, camera distortion, lens effects, bokeh effects, etc.?
Currently, you can't distort directly. We have a fisheye camera with distortion, but you can have a custom distortion. You don't have lens flare, but you can build procedurally a lens flare system in Clarisse. It's in a little rough way, but it works. But if you really want to easily build lens flare, it's better to do it in an external compositing application. But it's a nice example of what you can do without having lens flare in Clarisse. You can already build your own. I can just show you a nice example of the procedural nature of Clarisse. Okay, I think it is this one, yes. Okay, and I will load okay, so this one show sorry, I don't have my lens dirt file. I will just update the file. Okay. Lens dirt. Where is my lens dirt?
Can you export the camera and some null, like to AE or Nuke or something?
You can. Currently, you can't. With scripting, it's very easy to do this kind of things, writing a chan file. But usually, you use Alembic camera from external animation software, so you can very easily use the same Alembic camera in Clarisse and in Nuke. But if you design your camera in Clarisse, so you can see the flare lens reflection effect. This one uses a lens dirt, and it only uses standard Clarisse feature. It's using the compositing feature of Clarisse, using the HDR image with a very big blur and the dirt file multiplied on top of it. And I have another one with lens reflection. Okay, so this one is a custom reflection system built in Clarisse. And if you look at how this system is done, it's very funny. Okay, it's just a null with a little sphere parented to it, and each sphere use a procedural texture, and all of this is rendered on an image on top of the regular render. And the center nulls point to a target. We have a constraint system, so you can look at the target. So you just have to place this to the brighter object or to your sunlight, for example, and you have your lens flare system. So later we may had a integrated lens flare filter inside Clarisse, but you can already design your own lens flare system this way.
Okay. With the displacement mapping, can you displace something and bake it into the geometry, like with the displacement modifier in 3ds Max?
Yes. If you have a displace modifier in, it depends. Of course, we have displacement in Clarisse. If you want to export, for example, an animated sea surface, it's okay to export the result in Alembic, but you can also export just a grid and some texture and displace it in Clarisse. For example, here is a sphere, and I will add a displacement shader to it. So displacement, okay. I will just change the tessellation to something higher, okay. And now just add some texture. We also support vector displacement map. Just change the bones. Okay. It's pretty fast system, but the displacement is especially useful for animated geometry, because if it is still geometry, for example a landscape, because Clarisse loads polygon very fast and don't use a lot of memory, it's easier to directly load the high resolution geometry without using displacement map. For example, if you work with ZBrush or with Mudbox, you can directly save your high definition version and load it straight into Clarisse. But of course, the regular workflow using displacement map is also here, especially for animated geometry.
Okay. It looks like there's not any more questions at this time, so if anybody has any additional questions, feel free to email me at brad@motionmedia.com, and I can get them answered for you. And again, if you're interested in a trial version, send me an email, and I can get you hooked up with that. So thank you, Jan, and thanks everybody for coming. Hope you enjoyed it, and we look forward to answering any questions that you might have.
Yes.
All right. Thanks, Jan.
Thanks.
Bye, everybody.
Thanks to everything.